Okay, so before we get into the nitty gritty of acids and bases, let's kind of look at some definitions that you guys need to understand, right? Let's start off with neutralization. What is neutralization? So remember I talked about how Laurie and Bronsted focused more on how an acid and a base react, and the acid is basically going to transfer a proton and the base accepts it. So neutralization is also a type of reaction where an acid and a base react together. Here's our acid, hydrochloric acid, and sodium hydroxide, our base. They react together to form a salt and water. Okay, that's basically what happens here. It's a type of reaction that happens. You can even do it in the lab. So now, another definition I want us to touch on a bit is titration. Some people usually think titration, neutralization, same thing. Not so. So titration is a lab technique where, yes, you're about to react your acid, hydrochloric acid, with your base, sodium hydroxide. But when you go to the lab, you know the concentration of your base, 0.2. You know the volume of your base, 20 cubic centimeters, but you do not know the concentration of your acid. That is a titration reaction. It's where you're trying to figure out the concentration of an unknown solution, meaning you do not know the concentration of that solution, but you're going to utilize the concentration of a known solution. You know the concentration of your base. You can therefore find the concentration of your acid. That is what titration is. But now I want us to go through each step. How exactly do we do that? Cool. So now we're going to look into how we can use the known concentration of our base to find the unknown concentration of our acid. And there's this little phrase that I like to use called 2 formulas, 1 connection. Because here we usually use 2 formulas, where if you're given the concentration, you can use the concentration formula. Later on, we're still going to look at what if you're not given the concentration, but you're given the mass? Because I know the definition of titration is using the known concentration to find an unknown concentration. But sometimes concentration is not what's given. Sometimes you're given the mass, but we're going to look at that a little bit later. Right now, let's use this phrase, 2 formulas, 1 connection, and the connection being mole ratio. So let's start it off here. First step, you read your question, you see what you're given, and you focus on the solution with the known concentration or the known mass, because that actually gives you a lot of information. For example, our sodium hydroxide, we are told that it has a concentration of 0.2 moles per cubic decimeters, but it's got a volume of 20 cubic centimeters. Now, first things first, 2 formulas, 1 connection. The formula that you can use in this instance is the concentration formula. Concentration is equal to moles over volume, because you know the concentration and you know the volume. So if you say 0.2 is equal to the number of moles over the volume, here the volume is 20 cubic centimeters. Guys, emphasis on the fact that you need to convert your volume from cubic centimeters to cubic decimeters. And to do that, you have to multiply by 10 to the power of negative 3. So 20 times 10 to the power of negative 3. Or you just divide by 1,000. But your volume always needs to be in cubic decimeters, right? So here you have to put 20 times 10 to the power of negative 3, because that is in cubic decimeters. Then you go on and you can calculate here and you can find out what answer you're going to get. Okay, so from what we're basically doing here is we are trying to find out exactly just how many moles we actually have in this type of solution. Okay, and we see we've got 0.004 moles. Okay, now the next step, the connection. So the way that I like to look at this, and the reason why I call it the connection, is because it's like a recipe. If you think of a recipe where they tell you you need to use 2 spoons of oil and let's say 1 spoon of water and 250 milliliters of milk, that is exactly what this is. It is a recipe. If you guys remember the reaction between hydrochloric acid and sodium hydroxide, we are told that it makes a salt and water. Okay, that's what we get here. This is a recipe. You see here, this is a 1, 1, 1, 1. If you guys remember balancing from grade 10, whenever there's no number in front of a reaction like this, it means there's basically a 1. But you don't have to write it there. You remove it. So that's exactly what's happening here. We're told that for every 1 mole of HCl, it is going to react with 1 mole of sodium hydroxide, and those two are going to form 1 mole of sodium chloride and 1 mole of water. Okay, now I want to show you guys in the form of a picture. So let's say, for instance, in here we've got, let's say, HCl. I'm going to draw a couple of moles of HCl, okay? And then we've got some sodium hydroxide, sodium hydroxide, sodium hydroxide. Okay, so what this recipe tells us is that in this type of reaction, 1 mole of sodium hydroxide, 1 mole of HCl, and what is that going to form? That is going to form 1 mole of NaCl and 1 mole of H2O. Again, 1 mole of HCl, 1 mole of sodium hydroxide will form 1 mole of sodium chloride and 1 mole of H2O. That is our recipe. That is our connection. And that connection is our mole ratio. It tells us a story. But these numbers, guys, emphasis on the fact that these numbers, they're an ideal ratio, okay? It's where you have exactly 1 mole of hydrochloric acid and 1 mole of sodium hydroxide. Now, in this situation, we calculated that we've got 0.004 moles of HCl. So now the question would be, exactly how much is it going to react with, okay? So here we were basically told that we essentially have 0.004 moles of sodium hydroxide. So our question is, but in this recipe, how many moles of HCl is going to react with it? That is the connection, and that is when you use mole ratio. So if you write down mole ratio, I know you guys can do it in many different ways, but this is how I do it. I say the ratio of HCl to the ratio of sodium hydroxide, because I'm basically saying how many moles of this will react with moles of that. Okay, how many moles? Because I know that the ratio is 1:1. For every 1 mole of HCl, it will react with 1 mole of sodium hydroxide. So now if I create a ratio of 1:1, I can say, okay, cool, but I don't have 1 mole. I have 0.004 moles of sodium hydroxide. So exactly how many moles of HCl will react with that? And then you can cross multiply. Okay. And then from here, we can actually find that the number of moles of HCl is 0.004 moles. Meaning, if you're going to use 0.004 moles of sodium hydroxide, you're definitely going to use 0.004 moles of hydrochloric acid. That is the link between the two. It's a recipe. You want to know how much you need of this, or how much of that will react with how much of